As we continue this lesson on quadratic applications, we're going to look at some geometric applications. Here we have a parking lot that's going to be constructed adjacent to a road. So adjacent just means next to. The developer has purchased 340 feet of fencing, and we want to determine the dimensions of the parking lot that will maximize the area. So think about there being a road and you building a rectangular parking lot beside it. We don't know how big that rectangular parking lot is, but we do know that we're going to have a limited number of fencing. We can let one side be x, so I'm going to choose this top side here, this rectangle that I drew. Because that side is x, then the opposite side would also be x since it's a rectangle. And I'm going to let the third side be y. There's no need for the other side to be y because this is going against the road, and if I put fencing here, then I won't be able to get into the parking lot. So we only need 3 sides of this fencing. What we have is a limited number. So if I put both x's, so 2 x's, and 1 y together, it should give me all 340 feet of fencing. We want to create an equation that's going to maximize the area. Well, the area of this rectangle is length times width, which is x times y. So I'm going to write another equation that says area equals x times y. This function has 2 different variables, and we can't really work with a function that has 2 different inputs. So we're going to use the other equation that we drew so that we can solve for one of the variables. This one's pretty easy to solve for y. I just get y by itself by subtracting the 2x to the other side. So that would be 340 minus 2x. What that represents is if we had 340 feet of fencing and I use 2x of it, then that's the amount left over. So if I were to use what we just found for y and substitute it into our area equation, we can take this y equals 340 minus 2x and substitute it into that y. This makes this area equation x times 340 minus 2x. If I were to distribute x, I would have area equals 340x minus 2x squared. This is a quadratic equation, and it will have a maximum. It's pointed down because our quadratic term is negative. And if you wanted to reorder that, you can. You don't have to. The area is 2x squared, negative 2x squared, plus 340x. But both equations are fine to work with. What we want to do is find that maximum. Since the maximum is at the vertex, let's find that vertex first. We're going to use that negative b over 2a method to finding the vertex. So x equals negative b over 2a. In this equation, b is 340, so negative 340 over 2 times a, which is negative 2. Putting this into my calculator, we get 85 as x, which is the x coordinate or the input of our vertex. So I know that this vertex happens at 85, and the y value or the output is something attached to that. So let's find the area when x is 85. That would be negative 285 squared plus 340 times 85. And if I plug that in, I've got plus 340, 14,450. So there's our vertex, and we want to interpret what do these values mean in context of this problem. So we found x to be 85 and a, because that's our output of the area function, to be 14,450. That means if I let this side be 85, x be 85, then the maximum area would be 14,450. If I need the dimensions of that, we already have how big x is. It's 85 feet, but we need to determine what y is. We do know something about y. Y is 340 minus 2x. So if I want to use that equation and substitute x in there, that would say 340 minus 2 times 85. So y should be 170. If our rectangle is 85 by 170 feet, we get our maximum area. In this case, the maximum area was 14,450 square feet. It's square feet because we're talking about area. In the last example, we have a rectangular pen that's being constructed, and we again have a limited number of fence, or a limited amount of fence. So the fencing is going to form 3 equal rectangular adjacent corrals. Once you see a picture of this, you'll have an idea of what that means, but we have a rectangle that's been divided up into 3 equal corrals. Adjacent just means that they're next to each other and they are all touching. We're going to make this whole figure out of that chain link fencing. We do not know the dimensions, so I'm going to let one side be unknown x, and this is that left side for me. So if that's that vertical height, then all of the parts that are vertical, since we're making a fence on every single piece, would be x. The top part can be our unknown y, but we are putting this around the entire pen, so there's 2 of these y's. If all of this is fencing, then 4 x's plus 2 y's make up the whole 1,200 feet of fencing. And we're still looking for the maximum area. The area of this rectangle would be x times y. But again, we have 2 different inputs. So we were going to solve for one of these values. I'm going to still choose solving for y, but I would need to subtract the 4x over, so that's 1,200 minus 4x. And then we're going to divide by 2. Dividing both sides, the whole side, by 2 makes that 600 minus 2x. So if y is 600 minus 2x, I'm going to use this and substitute it in for y. So our area equation says x times 600 minus 2x. Or if you distribute, that's 600x minus 2x squared. Again, we're trying to find the maximum area, so we're going to be looking for the maximum of that parabola, which is at the vertex. So if I find the vertex, x equals negative b over 2a. Negative b would be negative 600 over 2 times negative 2. Make sure that you're looking at which one's your ax squared, your quadratic term, and which one's bx, the linear term. When I divide this out, I have negative 600 divided by negative 4, which is 150. So the x part of our vertex is 150. And we can find the area based off of that input. So it was 600x, that means 600 times 150, minus 2x squared, so minus 2 times 150 squared. Plug this back into your calculator. We get 45,000. All right, so we can use that vertex to describe the dimensions and the maximum area. So in this case, dimensions, we found x to be 150 feet. And we only need y, or we need to figure out what y is. But we do have an equation that says y is 600 minus 2x. So if I plug that in there, 600 minus 2 times 150, since x is 150, we get 300. We want a rectangle that is 150 feet by 300 feet, which would give me a maximum area of 45,000 square feet.